Alright, hello, and welcome back to my new series, which is 2D Left 4 Dead in Unity, which won with a whopping 2 votes. So, yeah, let's get on to this. Basically, for this first episode, we're just going to be creating up a basic character controller. So, if you see, we've got this vaguely reminiscent of Zoe sprite. Well, not sprite, it's actually made up of a load of different components because of how I'm choosing to animate this one instead of having like sprites of individual animations. I'm going to have like it made up of little body parts and stuff. So yeah, that'll be something to go on. I'll just download it quickly for you. So you can see we've got a walking animation. We can move, rotate towards a mouse, and you'll see that the friggin' thing will, the legs will animate. But we don't even have. It's not sprite sheet based. It's like using Unity's animation system, which I'll give a quick demo of. Well, quick explanation of how to use it in this episode. So yeah, let's get to it. Okay, so first off, we've basically just got it's just a basic person movement script. So I've got a movement speed variable, a rigid body 2D variable, and a boolean to see if we've moved this frame or not. On awake, we just get the rigid body and store it, and then instead of like just referencing the actual variable for the movement speed, we've got a method to return it. So just get movement speed, which you'll see we use in move in direction. The reason for doing this is, in Left 4 Dead, like as you lose health, your speed will decrease, so you'll start limping and shit and stuff like that. So basically, we could add, say, so if how much call that? If health less than 50, return movement speed divided by 2, or something like that. So that's why we've got these in methods rather than just using the variable. And we've got a similar, well, identical thing for rotation. So we've got rotation speed, and we've got rotation speed, get rotation speed, and we return rotation speed. But we could modify that in any way based on variables that the player has or something. So yeah. And next up, we've got a method called move in direction, which basically just takes in a direction and will transform us in that direction, the direction passed in, and multiplied by movement speed and time.delta time. And remember, if you don't know what time.delta time is, it's just the time that has passed since the last frame was rendered. So it keeps everything sort of trying to think of a word. But yeah, so it just keeps everything nice and smooth as long as you've got a smooth frame rate. And if you like your frame rate tanks for some reason, then it won't like keep processing it. It'll just do. I'm fucking up this explanation. Sorry. It's like it'll keep it in sync. So no, oh well. I hashed it up. But basically, time.delta time is just the time that's passed since the last frame was drawn. We do it in the space at will because we want to move it relative to world space. And we've got a similar method for rotation. So we pass in a vector free, which is the position to face. So in this case, we pass in the mouse position, and we get a ROP for a new vector free. We do math.atan2 for the z-axis because since we are in the top-down perspective, we only want to rotate on the z. This will actually, you'll see that we can rotate there. If we rotate on the y, it does some funky shit, and we don't want that. And same with the x, so only rotate on the z. So we do some maths here. So we've got mathf.atan2, and we pass in twoface.y minus transform.position.y, and then comma, then twoface.x minus transform.position.x. And then we multiply that by mathf.radians 2 degrees. So we can pass this into a Euler in a minute. Then we set the rigid bodies rotation to be quaternion.slurp. Actually, we don't need to set it for rigid bodies, do we? No. Oh well. It is the same thing, so we'll leave it for now. yeah, quaternion.slurp will basically just move us between two rotations passed in. So in this case, we are passing in the current rotation of the player object, or the object that the script's attached to, and then it will rotate to the new rotation. So in this case, it's rotx, roty, and rotz minus 90, because we need to add minus 90 so it faces the right way. Well, take 90 from rotz. I'm not sure why, but we do to make it work. I think it's the way because of the way the it faces, because it's all a child object. So if we were to rotate this like 90 degrees that way, then it'd probably be right. But just to keep things all simple, we're just gonna have everything face up, and then yeah. Next up, the next argument for slurp is just the speed you want to rotate at. So in this case, we are using get rotation speed and multiplying that by time.delta time to keep it all smooth. And finally, we have on update function, we just set move this frame to be false. And the reason for that, I'll explain once we get onto the animation. Okay, so next up we have the player input script, and these are both on like the parent object of the player character. So you'll see that we've got the person movement script and the player input script, and we don't need those positions frozen. And what this script does is basically just listens for input from the keyboard and will call methods in the person movement script based on that. So see, we've got an instance of the person movement script, and on awake we just get that off the same object that this script's attached to. Then on update we call two methods, rotate and movement. Rotate basically just calls the person movement dot rotate to face direction, and we'll pass in the mouse position as world coordinates using just camera.main.screen to world point input.mouse position. So yeah, that's simple. Next up is movement. So basically what we do is we start with vector 3.0, we just store under move direction, and we listen for W, A, S, and D keys. And for each of these, if the key is pressed, then we add the respective direction. So for W, it's vector 3.up, S, vector 3.down, input.get key. Oh, sorry, key A is left and D is right, and you get the idea. And then if the move direction is not equal to vector 3.0, then we call pm.moving direction move direction.normalized. And remember, normalized just will convert a vector to be the sort of like the same scale of vector. So I'll just show you this. 9, 9, 9. So that normalized would just be the same as 1, 1, 1. But instead of moving like 9 units of time, just move the 1, if that makes sense. So we're just trying to make it a magnitude. We're trying to make the vector between a value of 0 and 1 for each of them, but in the same direction, so that we can just use this as we're saying a direction rather than how fast to go, and how fast the object will move is based on some other value. In this case, it's the person movement script's movement speed. So yeah, and likewise, if the sum of the values is equal to vector 3.0, then we don't need to move because you can't move on 0. You could take that out if you wanted to have a little moonwalking animation, but yeah. And finally, after this, we've got another script just called the camera movement script. It's got bool for do we follow object and game object for object to follow. This basically it follows the object really. So if do we follow object is true, we follow the object, call the follow the object method. First off, we have a check here. So if the object is null for any reason, then we say do follow object is false and then return. Otherwise, we set the position. We get a position, which is basically the camera's Z position combined with the object we're following's X and Y position. And finally, we set the transform of the camera to be that new position. So it's just that. Now, the reason we do this in late update instead of update is to make sure that any movement that's happened in the frame has been done before the camera has to move, which makes sure it's smooth. Because I think if we do this, so I'm not commented that out. So if we have it in update instead, it'll appear janky, what it should do. Oh, it did when I tried it before, but yeah. So that is the reason why we have it in late update. And hopefully, if I do this, it will be a bit smoother. So yeah, it seems a little bit smoother, that. So yeah. All right, so finally, we're just going to go over how these characters are going to be animated. Instead of using just sprite sheets of stuff, which I've usually used, we are going to use Unity's animator. So I'll just give you a quick demo of how that works. So first, you'll see that basically this is the leg animation as we have. So you'll see that the legs are built up of like the thigh, then the child of that is the calf, then the child of that is the foot. And what I've done in the animation is basically just move them over. We can move them to positions and like set keyframes for that. And then Unity will slurp, or like move the legs, the different parts smoothly between the positions in the animation. And that gives the illusion of a walking animation without having to do the individual shit, really. So yeah. So let's just create a quick animation. Sorry. And I've also got this new one. This new one. This is also the animator. So you use this animation thing or animation window for actually creating the animations. So if you wanted to, I'll show you how to create them in a minute. Yeah, this is also setting up how they sort of work in the game. So in this case, you'll see we've got our entry point here. This is the starting location. These arrows are called transitions. You just right click and make transition, and you can just drag them and drop to anywhere. I just want to get rid of that. So first off, we just have a transition to our movement check. This is just an empty state. It doesn't have an animation, but you can create it by create state and then empty. And then, yeah, you can do that. Next up, we've got movement check. So basically what this does is it has a little transition here to check if we are moving or not. So you'll say if move this frame is true. So you remember the move this frame variable that we had in the person movement script that is linked to this bit in the animator. And you'll see that there's a variable called has exit time here. This basically means that if you click it to true, you'll wait for the end of the animation before transitioning. And then, so if move this frame is true, then we just play the animation walking. And likewise, this is a little arrow here, which is just a transition again. This is basically just, if move this frame is true, then we'll just replay this animation, and you'll see that we've got has exit time selected, so that we want to wait for the end of the walking animation before playing the next iteration of the walking animation, so we don't like keep restarting it over and over again. And likewise, we've also got another transition from walking. So if move this frame is false, so if we stop moving, what this does is it basically just moves back to movement check and stops the animation for walking playing. Now, just for this, I will show you how these are linked with the person animation controller. I don't know why that's that. Oh well. So, I shouldn't have clicked off that. So yeah, basically we've got a script called person animation controller, and this links up with the person animator, which is what we are currently using for our legs to animate. Then, person animation controller. Basically, got a public animator, which is our leg animator. You create these by just clicking right-click, create, and where is it? Animation controller. There we go. So let's say arms. We'll do an arms animation in a minute. So that's how you create an animation controller. We've also got a link to the person movement script. We get that on awake, we just get it from the parent, because this is on the sort of like parent of the body, which has the torso sprite. And what this does is basically just on update, we call leg animator.setBool. So you can set like these parameters, which you add by doing this little button here. So you set that, you can add floats, ints, bools, and triggers. So like say, you could add an int, say if you wanted to choose between a couple of different animations randomly, submit a bool if you wanted to condition. I don't know what a trigger does, to be honest, and I don't have any reason to use a float over an int. Maybe I will in the future. Maybe it's for like deciding health if you have some kind of minute detail or speed or whatever. Whatever. It doesn't matter. Float and bool are the ones I tend to use. Not float and bool? Int and bool. So yeah, basically what we do is we set the bool, we pass in the name of the parameter in the animator. So in this case, we've got move this frame, and you'll see that it links up with move this frame here. And we pass in person movement dot move this frame. So if the player is like pressing WASD and moving, then the legs get animated. But when we stop doing that, it goes back to movement check. And you'll see, yeah. So that's pretty much it. Finally, I'll just create us a quick animation. So where did I put it? Animations, arms. So I'm just going to add, can I have 2 on this? Oh no, I can't, shit. Okay. I think I could have it on this one then. See if I can animate the arms separately. Animation, animator. And if we just shove arm in here, then animation. So we can create a new animation clip for a right arm. Have we got it selected actually? Arms, animator, yeah. So create. We'll just save the animation as wave. I'll just do like pick up object. Save. So first off, we've got our pick up object animation. So we want to actually set stuff. Wait for this, something for this to do. So if we click this red button here for recording, we'll be able to set stuff for the animation. So if we've got right arm, we can just do this. So say we'll set it to like that. And then we have a keyframe at say 0.02 seconds. So we'll move the arm out to here. Rotate the left arm in just to hide it. What have I done to the right leg? Why has it changed to the walking? Fuck's sake. Oh, good stuff. Fucking switched it off. Okay, so I can only animate the right arm, right? So yeah. Sorry. So yeah. So if I click record here again, I'll just move the right arm to there. Then if I go to 0.4, I will move the let's see, lower arm so it's stretched out. Then 0.5, we'll move the hand to be straight. And then 6, we will reverse all this. So lower arm, 7, we'll rotate that. And for 0.8, we will rotate the arm like there. And yeah, so if we click off the record button now, we can click play, and we'll see that we have an animation vaguely. So it's like grabbing something and just shoving it in pockets or something. So yeah, that's the basics of how to create an animation with this system. I know it's a bit shit of an animation, I ain't working for Pixar, but you'll get the idea, and if you want to spend more time on that to have nice, smooth animations that don't look like shit, then that is your goal. But I'm just here to give you a tool. It's up to you what you do with it. So yeah, that was the character creation episode. So if you like that, like, comment, subscribe, all that shit. I'm on Patreon if you want to support me. And once we finish this, then you'll get to choose the next one. You'll also be free to ask me questions about this tutorial series. You'll get early access to the files, all that good stuff. So yeah. Cheers for watching and goodbye.